isotope is available for carbon. C12 is a natural isotope and which is available in higher abundance, and isotope of C12 is C13 which is 1 mass unit higher. Similarly, H1 also isotope deuterium which is 1 mass unit higher, and nitrogen 14 which has also 1 mass unit higher nitrogen 15 isotope, and M plus 2 peak is a count for those elements having a 2 mass unit higher isotope, oxygen, sulfur, bromine and chlorine element having a 2 mass unit higher isotope. Now, here we see the mass spectrum of methanol molecule and its fragmentation. So, in this figure I have shown that methanol molecule is bombarded with heavy beam of electron and molecular ion is produced. So, that molecular ion undergoes further fragmentation. So, two parts is there, 1 and 2. So, in this figure it is shown mass spectra of methanol. So, different peak is obtained here. Here peak correspond to M by Z value 32. This peak is the molecular ion peak. So, they are the cluster of peaks. So, last cluster is a molecular ion group. So, this peak is correspond to molecular ion and then next peak is 31 which is 100% of that, which is called as base peak. So, peak having a 100% relative abundance is known as base peak, and other peak intensity is related to the base peak is registered here. Similarly, peak at M by Z 29 and 15. So, these are the fragment ion peak. So, in this figure it is shown that first of all methanol molecule is removing H radical in part number 1. This is part number 1. So, CH2H bond is broken down and H radical is eliminating, and CH2 group having also 1 electron, it will combine with this electron and double bond is formed. So, it will form a cation CH2 double bond OH plus M by Z 31. Now, this fragment ion loses H2 molecule from both carbon and oxygen atom. So, H radical from here and H radical from here, and both H radical combine to H2 molecule. So, here triple bond is formed and another fragment ion M by Z 29 correspond to molecular weight, molecular mass of that ion, and which is registered here at 29. So, relative intensity is roughly above 50. Now, in second part fragmentation in this mode. So, carbon oxygen single bond is broken down and OH radical is eliminating. So, this carbon having a 1 electron, OH radical is eliminating. So, whole pair of electron is here, OH radical is removed. So, CH3 plus cation is formed and having a M by Z value, M by Z value equal to 15 mass unit. Now, second spectrum is methane molecule, mass spectra of methane here. So, in this mass spectrum of methane, these are the cluster of group. This is the molecular ion group. So, from molecular ion group, you find out first of all parent ion or molecular ion peak. So, here molecular ion peak is found at M by Z 16, which is correspond to M molecular weight of the methane molecule. So, here this peak correspond to M by Z value 16 having a highest intensity 100%, and it is also a base peak. So, in some compound molecular ion may be a base peak, but it is not always true. So, base peak and molecular ion is different in methanol molecule, but here it is same. So, those ion having a higher stability, molecular ion having a higher stability, then it is a base peak and it is also a molecular ion peak. Similarly, other peak also there, which is written here in this table. So, peak M by Z 1 correspond to 3.1% relative abundance. Similarly, 2, 12, 13, 14, 15, 16 and 17 mass unit M by Z value is given and correspond to relative abundance. So, fragmentation of methane molecule is shown here. Fragmentation, here it is written. So, methane molecule is bombarded with heavy beam of electron So, radical cation is produced correspond to molecular weight of the compound having m by z value 16. Now, molecular ion further undergoes fragmentation. So, it will losing H radical. So, 1 mass unit. So, m plus minus 1 peak is obtained. So, correspond to m by z value 15. This is methyl radical or cation. Similarly, this molecular ion losing H plus ion and methyl radical reverse. So, m by z 1 is there because radical is not registered in the mass instrument. So, it is not detected, only cations is registered and it will be detected in the detector section and giving a peak into the mass spectrum. Now, methyl cation further undergoes fragmentation and H radical is eliminating and we get m by z value 14 CH2 plus radical, radical cation is obtained. Now, this radical cation further losing H radical and we get CH plus cation having m by z value 13. Similarly, CH cation also undergoes fragmentation losing H radical and C radical cation having m by z value 12 is obtained. Similarly, molecular ion undergoes fragmentation, CH2 radical is eliminating and H2 plus correspond to molecular m by z value 2 is obtained. This is the mass spectra of methane molecule which is shown here. So, H2 radical cation having m by z value 2. Now, this table showing the isotopic abundance of different elements. So, natural abundance of other isotopes based on 100 atoms. So, this table showing the natural abundance of other isotopes based on 100 atoms of most common isotope. So, different element is there: carbon, hydrogen, nitrogen, oxygen, fluorine, sulfur, chlorine, bromine, iodine. C12 having a 100 atom, so correspond to C13 1.08 natural abundance, higher isotope. So, in generally molecular formula, those isotope, lower isotope is counting for molecular weight determination. Now, important terms of mass spectroscopy. So, first is base peak. The most intense peak in the mass spectrum is called the base peak. It is assigned a relative intensity of 100% and the intensities of the other peaks including the parent peak are expressed as percentage of the base peak. Second term is molecular ion or parent ion. The ion formed from a molecule by the removal of one electron of lowest ionization potential is known as molecular ion. The energy required to remove an electron varies in the order lone pair is less than conjugated pi, less than non conjugated pi, less than sigma. The molecular ion detected as mass to the charge ratio that correspond to the molecular weight of the molecule. So, here methanol molecule is bombarded with heavy beam of electron. So, one electron is removing, so it will form a radical cation. So, lone pair of electron is removed because it has needed lowest ionization energy. The lone pair of electron require lowest ionization energy to remove the electron from the molecule. So, m by z value or m by value correspond to methanol molecule is 32 and that shows the molecular mass of the compound. Now, parent ion which describe the precursor ion of a metastable transition. Now, similarly methanol, like methanol, other ion also there, ethylene, say for example, ethylene ion on bombarded with heavy beam of electron. So, ethylene ion can be written like this. So, double bond in ethylene molecule is written like this and one electron is removing. So, it will form a radical cation like this way. So, ethane molecule is there like this way, ethane molecule is there. This ethylene molecule is bombarded with heavy beam of electron. So, pi electron is written in dotted form. So, one electron is removing, so electron is negatively charged particle removing, so produce positive charge. So, radical cation is produced like this way. Similarly, benzene molecule is there, benzene molecule. So, here 3 pi electron is there, it is written like this, sorry, 2 electron is there, 2 electron, and then bombarded with heavy beam of electron, it will produce radical cation like this way. In general, it is written like this, or whole bracket is written, or sometime it is written like this, not this type. So, this is the molecular ion. Now, mass to the charge ratio. Mass to the charge ratio, which is known as m by z or m by e. So, it is a dimensionless ratio of the mass number m of a given particle to the number z of the electrostatic unit E carried by the particle. Third point is relative intensity. So, the relative intensity of a given peak expresses its intensity relative to that of the base peak. The most intense peak in the mass spectrum, the relative intensity of the base peak is arbitrarily assigned as 100%. Another term is fragment ion. The ions produced from the molecular ion by cleavage of bond are called fragment ions. They have lower masses and are used as building block to reconstruct the molecular structure. Another term is nitrogen rule. So, nitrogen rule state that the compound containing an even number of nitrogen atoms including 0 is an even number, will give a molecular ion with an even mass number. So, this is the example, CH4 methane m by Z16 does not contain nitrogen atom. Methanol even number molecular weight 32 do not contain nitrogen atom. This hydrogen molecule having m by Z value 32, even number of nitrogen 2 nitrogen is contained. So, it is even number. So, molecular mass is also even. Similarly, C5H5N2 molecule m by Z value is 94, which is even number. Here even number of nitrogen is there in the molecular formula. An odd number of nitrogen atoms causes the molecular ion to be at odd mass number. Say for example, we have seen the fragmentation of ammonia molecule correspond to m by Z value 17, which is odd number. So, ammonia molecule having a odd number of nitrogen atom, so molecular mass is odd number. Similarly, ethylamine also contain odd number of nitrogen. So, molecular mass also m by Z value is given 45, which is odd number. Now, Mclafferty rearrangement and ortho effect. So, first of all we will discuss here Mclafferty rearrangement. So, in this rearrangement it involves the migration of gamma hydrogen atom followed by the cleavage of a beta bond. The rearrangement leads to the elimination of a neutral molecules from aldehyde, ketones, amines, unsaturated compound, substituted aromatic compound, etc. The rearrangement proceeds through a sterically hindered 6-membered transition state. So, here those compound giving this Mclafferty rearrangement which having a gamma hydrogen. So, after carbonyl group, say for example, gamma hydrogen comes from alpha, beta and gamma carbon atom. Those hydrogen atom attached to the gamma position is known as gamma hydrogen, and after rearrangement this gamma hydrogen is losing and it will be proceeding through a 6-member transition state, which is shown in this diagram. Rearrangement is shown in this equation here. So, this is the compound, general compound, R is a substituent. So, carbonyl compound is there, this is ketone. So, here this is alpha carbon, beta and gamma carbon. So, gamma hydrogen is eliminating by loss of beta bond. So, this is beta bond. So, beta bond is transfer it electron and neutral molecule is lost here. So, this rearrangement is proceed via 6-member transition state. Bond making and breaking is shown by dotted line here. So, those bond is making, it is also shown by dotted line, and those bond is breaking, it is also shown by dotted line. This bond is making here, so it is shown by this carbon hydrogen bond is breaking, it is also represented by dotted line. So, this rearrangement is proceed via this 6 member transition state TS, and finally is rearranged to molecular Mclafferty rearranged ion. So, here R is substituent, different group is there, then various classes of compound is there. Here one of this example is given, butanol contains a gamma hydrogen, this example is for butanol, here R is in general it is H. So, it is butanol molecule. So, in butanol there is gamma hydrogen, alpha, beta and gamma. So, gamma hydrogen is removed via 6 member transition state, it is not written in this example, and we get Mr ion at M by value 44, and by the loss of neutral ethylene molecule. This ethylene molecule is neutral, not giving in the detector section. So, it is this neutral molecule is not registered in mass analyzer, that is why M by value is not given. And this peak is Mclafferty rearranged ion peak, and in some compound it is probably a base peak, it is highly stable radical cation. So, here in this compound R is a substituent, if R is H, then example of butanol correspond to M by value 44, Mr ion peak at M by 44. If R is CH3, then it is ketone, M by value is 58. Similarly, R is substituted by NH2, it is amide and M by value is 59. R is OH, carboxylic acid, M by E is 60. R is OCH3, methyl ester, M by E 74. Now, more example of Mclafferty rearrangement are, this is the 1 pentene undergoes rearrangement and neutral ethylene molecule is lost, and Mclafferty rearranged ion is obtained at M by value 42. Similarly, this is the ketone, aromatic substituted ketone. So, aromatic aliphatic ketone. So, aliphatic chain terminal hydrogen is replaced by phenyl group, and we get neutral molecule as a styrene after rearrangement, and Mclafferty rearranged ion is obtained at M by 58, and this is in general it is ketone, R is methyl group. So, Mr ion is 58 as shown earlier. Similarly, other example of this rearrangement is written here. So, aryl alkyl, so alkane chain is substituted at phenyl ring. So, here propyl benzene is there. So,